Thank you, students. Today we will discuss about thermal expansion of liquid. First of all, liquid has no dimensions, so it has no linear expansion. Also, it has no particular surface area. That is why also it has no superficial expansion. So liquid has no linear and superficial expansion. It has fixed volume, so it has only cubical expansion. This cubical expansion depends on original volume of the liquid, rising temperature and nature of the liquid. But when you heat the liquid, then you have to consider the expansion of container also, because when you heat the liquid, must you have to use the container. When liquid is heated, you have to consider the expansion of container in which the liquid is kept, and that is why there are two types of volume expansion of the liquid. One is the apparent expansion of the liquid and another is the real expansion of liquid. Now the real expansion of liquid, before going to the real expansion of liquid, first you have to explain what is. Say it is a container and the liquid is kept up to A. Now this is the original reading or original volume of the liquid. Now when you heat the liquid, then which will be heated first? The container will be heated first. So container will be expand. If the container expand, then the liquid surface comes down, and say it is comes down ultimately at B. Then liquid starts to heated, then it expands. That means liquid starts to expand, then its volume starts to rise from B, and say it is ended at C. But when we observe, then you observe that the liquid level is raised from A to C. It is we see apparently, and this AC is known as the apparent expansion of liquid. But actually liquid expands from B to C, and that is why this is BC is known as the real expansion of liquid. And what is AB? It is the expansion of container, because due to the expansion of container, liquid level comes down. That is why AB is the expansion of container. Now if we consider the expansion of container, then we get the real expansion. If we do not consider the expansion of container, then we get the apparent expansion of liquid. Here, when the expansion of container does not consider with the expansion of liquid, then this type of expansion of liquid is known as the apparent expansion. Here the expansion of container does not consider, but when the expansion of container consider with the expansion of liquid, then it is called the real expansion. That means in case of real expansion, we consider the expansion of container. Now the relation between these three, that means real expansion, expansion of container and the apparent expansion, is real expansion minus apparent expansion of container gives the apparent expansion. This is the apparent expansion. How you get? This is the real expansion minus expansion of container, that gives the apparent expansion. So this is the relation between the real expansion, expansion of container, and the apparent expansion. Now what is the application of? Many applications are there. One of them is the thermal expansion of mercury is used in the thermometer for measuring the temperature. This is the one use of the thermal expansion of liquid. Thank you.